In this lesson, we're going to talk about how to handle errors called exceptions using something called the try-catch statement for exception handling. And we're going to demonstrate this with two examples, one division by zero and the second trying to open a file that doesn't exist. Let's look at a very simple division problem where we have a numerator and a denominator. We assign a value to the numerator, and then for the denominator we assign 0. If we try to perform a division using the numerator and the denominator, first of all, notice that the editor doesn't catch any errors at design time. That's because this is an example of something called a runtime error. If we try to run the program, you notice that it looks like it's trying to work, but then we get an exception. Divide by 0 exception was unhandled. Attempted to divide by 0. So clearly if we tried to do this in a program, the program would crash, and that's the very last thing that we want. We want to be able to handle these exceptions. So the way we handle the exception, or the way we handle any exception, is by using something called a try-catch statement. The try-catch statement allows us to check to see if a particular statement or set of statements is going to cause an exception, and if it does, we can handle it some way. Let me show you an example. So let's remove the division statement for now. To use try-catch, we start with the keyword try, followed by an open block, and then the statement that we want to attempt to run. In this case, numerator divided by denominator. And we're going to keep it very simple. That will be the only statement in the try. Then, to handle the exception, we catch it. And we catch it by passing an exception object to the catch part of our try-catch. We'll start out very simply by displaying just the toString portion of the exception. And what this is going to do is this is going to tell us what the exception is, and then we can deal with something else. So what we could do here is we might say, well, let's prompt the user to enter a new denominator. Enter a non-zero denominator. So we write numerator divided by denominator, or denom, and close out the catch. So now let's run the program. So rather than the program end, it showed us the message attempted to divide by 0. That's what toString does. Then we can enter a new denominator and run the program again and get the correct answer, 6. Besides toString, we can also just print the message itself. I believe that's a property. So let's give that a shot. Notice how much cleaner that is. Okay, so that's just the actual message. And there we get 4. And then finally, something else we could do. If we know the exception, we can call the object directly, like so. Same result. But this way we can specify a particular exception, like we know that this is the exception we're looking for. Now let's look at another example. Let's say we want to try to open a file to read data from it. So let's comment out this old code. So now we're going to do a couple other things. First of all, we need to import system.io. Now before we do that, let's create a file. So let's say string file name. And then let's say console write, enter a file name to open, and then file name equals console readline. Then we can say stream reader in file equals new stream reader file name. And then just to demonstrate how it works, let's write out the first line of the file. Let's run the program. Try it with a file name we think we know exists, c:\data\todo.txt, fixed enter, that's right. Now, let's run it again, this time with a file that we're sure doesn't exist, c:\data\mike.txt. File not found exception was unhandled. So you know where I'm going with this. Anytime we're trying to open a file, we need to handle the exception that the file cannot be opened, quite often because it was not found. All right, so you know what to do. Take the stream reader section of this code and put it inside a try statement. And we'll stop there. We could do more. And then, of course, catch. We can catch with the general exception, or we could catch with the file not found exception. So let's do the file not found exception. We'll call that FE. So we'll say console write line fe.message, console write, enter another file name equal console read line, and then stream reader in file equals new stream reader file name. Notice the problem. This goes back to scope. Notice that we define each one of these within a scope, either the try or the catch. They're in their own block. So we have a block level scoping problem. So what we need to do is move this out. And we've never done this just because I haven't really considered it important. We'll declare it above scope level, and then we'll just get rid of the declaration, leaving just the assignment. And now everything works just fine. So let's try it again. So we'll try to open c:\data /mike.txt. Could not find file. So then we'll say, oh, okay, that's not what I meant. I meant to do .txt and fixed enter. As with the other topics in this chapter, there's much more to say about try, catch, and handling exceptions than what I've shown you here. What I'm trying to do in this chapter is give you a flavor for some of the other features of the language that you can understand, and I believe you can easily understand what we're trying to do here with try-catch. So I would suggest you go back to some of the programs we've written previously, especially the to-do list program and all the other file processing programs, and add try-catch into those programs to make them more robust and handle situations where the file they're trying to open doesn't exist. So now we're ready to move to the last lesson for this chapter, and here we're going to talk about a somewhat new technology for C#, LINQ, L-I-N-Q, and how to use it into querying some of the data structures that we've looked at in this course.